All right, so it's going to say to find all the real zeros. Again, zeros means solutions. They can also call them roots. Those are the three words that they kind of interchange a little bit: zeros, solutions, roots. And it says state their multiplicity. And the multiplicity means how many times does that same answer happen. If it happens twice, you say a multiplicity of 2. If it happens 3 times, you say a multiplicity of 3. That way you don't have to write the answer multiple times. So you can either have it y equals or f of x equals, and it is going to be a polynomial equation. Sometimes they're going to be completely factored already for you. Sometimes they'll be partially factored. Sometimes they won't be factored at all, and we'll have to go through and factor them to be able to get our solution. All right, so the very first thing we're going to do is we're going to take y or f of x, whichever one is written, and we're going to replace it with 0. Much like we solved regular quadratic equations before, we're going to take, if it's completely factored, we're going to take each set of factors, we're going to set it equal to 0, and we're going to solve for x. The exponents tell me how many times that part occurs. So like if you'll notice, in the parentheses I have x minus 2 and I have a squared on the outside. That means that x minus 2 happens twice. So whatever answer I get for that, it's going to be a multiplicity of 2. With the cube, like x plus 3 to the third power, that means whatever answer I get for that piece is going to happen 3 times, okay? If it doesn't have an exponent, then it just means it's 1 and it will happen 1 time. So if I'm looking at my parts, I have 2x. Does that part seem to be completely factored? Yeah, we can't break it down, right? And then x minus 2, that is completely factored. There's no squared, no cubed, or anything that I can break down any further. And then x plus 3 is also completely factored. So what we're going to do is we're just going to take each one of these, starting with the 2x. We're going to set it equal to 0, and we're going to solve it for x. We're going to do each one of these one at a time, and then talk about their multiplicity, how many times it occurs, and how we write that answer. So if I have 2x equals 0, how do I solve that one for x? We just divide by 2. And so therefore x is going to be 0, right? 0 divided by anything is 0. And that only occurs 1 time because there's no exponent other than 1 on that x. Then I'm going to do the same thing with the x minus 2. I only need to do it once because the exponent will tell me how many times that occurs. There's no need for me to repeat the same equation multiple times if it's going to result in the same answer. So if I have x minus 2 equals 0, then I would just add 2, and that would give me what? 2 as my answer. And then I'm going to do the same thing with the last factor, the x plus 3. I'm going to set it equal to 0, and I'm going to solve it for x. We're going to subtract 3 over. And so then I get x equals negative 3. But that's not how I need to write my final answer. I'm going to put all of my solutions together. I'm going to use the exponents to let me know how many times that solution occurs, and we'll write it with a multiplicity, and I'll show you how to do that. How many times does my answer 0 occur? Just once. So I'm going to put 0, and then I'm going to put a comma. And then my answer 2, where x equals 2, look at the exponent on that part. How many times does that occur? Twice. So what I'm going to do is in parentheses, I'm going to say multiplicity of 2. Now multiplicity is a long word and sometimes confusing to spell. So we're just going to abbreviate it and put mult, M-U-L-T, okay? So we're going to say M-U-L-T. That means multiplicity of 2. And that lets me know that you know that solution of x being 2 happens twice. Does that make a little bit of sense? Okay. And then we're going to do the same thing. We're going to put another comma, and we're going to put our other solution, negative 3. And how many times does that one occur? 3 times. So in the parentheses behind that, we're going to write multiplicity of 3. and that's how we're going to leave our answer. Okay, so 0 happens one time. The 2, x equals 2 happens twice, so that's why we put the multiplicity of 2. Negative 3 happens 3 times, that is why we put the multiplicity of 3 there. Okay, so sometimes most of the work is done for us. Sometimes we have to do a little bit more work. All right, here we go. Here's the next one. Again, it can either be written with y equals or f of x equals, because remember f of x and y are the same thing and we can use them interchangeably. Okay, so I'm going to look again at each piece. First of all, we want to write 0 instead of y. We're going to set it equal to 0 so that we can find our solutions. We can find our zeros. We can find our roots. Multiple different ways we can say we're finding what x equals. All right, so let's start at the beginning. Taking each one of these to see if we can go any further. Does 2x to the third break down any further? No, but what it does mean is whatever I get for that, how many times is that answer going to occur? 3 times, okay? So we're going to set 2x to the third equals to 0. We're going to divide both sides by 2. 0 divided by anything is 0. And then if it's x to the third, to solve that, we just think, what are we cubing to get 0? And it would just be what? 0. So you can kind of take your cube root if you want. Probably not necessary since it's 0. And so x is going to be 0. But again, it happens how many times? 3 times. So I'm going to put multiplicity of 3 behind that. Then we're going to do the next factor, the x minus 6. We're going to set it equal to 0. We're going to solve that for x. And this answer occurs how many times? Just once. There's no exponent on the outside of that parenthesis. So there's nothing else I can do, no other solutions from that part. And so x is going to be 6 that one time. And then we're going to do this x plus 4. But when I finish that one, how many times is that answer going to occur? 4 times. Okay, so we'll set x plus 4 equal to 0. We'll solve it for x. And because of that exponent of 4 on the outside of that, we're going to write a multiplicity of 4. Okay, so I have to have the 0 with the multiplicity of 3. I have to have the 6, and then I have to have that negative 4 with a multiplicity of 4. Anybody have any questions? All right, we're going to take a look at number 3 because there's something that happens with number 3 that we're going to have to pay close attention to. If you will take a minute and write it down. So go ahead and do the first two. Work with the 5x to the fourth and work with the x minus 7 to the fifth. Hold off on that last piece because we're going to have to talk about it and then go back and look at what kind of solutions it tells us to give. So again, we're going to take the y and we're going to replace it with 0. And the reason we're doing that is whenever y is 0, that allows you to solve for x. Okay. So we're going to start with the first part. If I take 5x to the fourth and set it equal to 0, what am I going to get for x? 0, but it's going to happen how many times? Okay. So that is 0 with a multiplicity of 4. Then we're going to do this x minus 7, set it equal to 0. And how many times does that answer occur? 5 times. So that's going to be 7 with a multiplicity of 5. And then we're going to take a look at this last one. This one's going to give us a little bit of a different type of answer. X squared plus 16, you got to think back, like way back to when we did some factoring. Those are both perfect squares, right? But the only time we can factor perfect squares is if they're being subtracted, or those being subtracted. So this is what we're going to have to do. We're going to set it equal to 0. And we can solve this, we just can't factor it. How do I get that x squared by itself? Subtract the 16 over. Okay. Now we're pulling from some stuff that we haven't done in quite a while here. If I have x squared equals negative 16, how do I undo the x squared? We're going to square root both sides, right? Let me come over here. So that's going to give me x equals a couple of things. When we take the square root of both sides of an equation, there's one symbol that we have to put first. What is that? Plus or minus. And then we're going to have to see about simplifying the square root of not 16, but negative 16. Another thing that we're going to have to remember that we've done a while back. Remember, anytime we have a negative under a square root, we can pull it out as the imaginary number. So remember what we did? We split it up into the square root, not of I, sorry, wrote the wrong thing, negative 1 and the square root of 16. You guys remember doing that? Okay. And what is the square root of negative 1? I. And then what is the square root of 16? 4. So it does give me two answers. It gives me plus or minus 4i. However, let me scroll back for just a second. What kind of zeros did the directions tell us we wanted to find? Real. Are imaginary solutions real? No. So because it specified that I want real solutions only, would I include that positive or negative 4i? No. If it told me to find all of the zeros, I would include them. But because it specified real zeros only, I'm going to just kind of throw those away. And I'm only going to give my real zeros as my solution. Okay. They can be solved. We can find a solution. It is just going to give me an imaginary solution. And the directions told me to find real solutions only. We will get to the point where we're going to include them all. Okay, but for right now, we're focused on the real solutions only. That make just a little bit of sense? All right, if you haven't already, take a look at number 4. I'm going to do this one with you, and I'm going to let you try 5. Okay, this time it's f of x equals, again, f of x, y. It doesn't matter which one we set it equal to. Before we start trying to solve this, we're going to replace it with what? 0. So I'm going to start by writing this as 0. Does this problem look like the rest of them? No, it's not factored for me, so we're going to have to think about how we factor. Okay, got to dig deep now. The first thing we do when we factor is we always look for a common factor, a GCF. If I have x to the third, x squared, and 2x, what is it that they all have in common? An x. So what we're going to do is we're going to pull that x out first. And if I take an x out of each one, what would be left? Okay, I know it's been a while since we factored, but I told you back when we factored that it wasn't going to go away. It would come back and come back and come back. So now what we need to do is focus on the inside of this parenthesis and see if we can continue to factor it any further. How many terms does it have? 3. And if it has 3 terms, we're looking in front of the x squared first. Is there a number in front of x squared? No. So this is one of the easier ones. Let's see if we remember. We want numbers that multiply to give me 2. And we want them to subtract to give me what numbers in front of this x right here? A 1. So I'm looking for numbers that multiply to give me 2 and subtract to give me 1. What multiplies to give me 2 and subtracts to give me 1? 2 and 1. And then we got to remember our signs. If the second sign is a minus, that means my signs are going to be different. And then the first one goes in front of the bigger number. So what's bigger, 1 or 2? 2. So we're going to put it there. Does that look like it's completely factored now? Okay. Now it's going to be like the first 3 questions that we did. You set each factor equal to 0. And you solve. Okay, set each one equal to 0 and solve. We have 3 parts. We have the x that needs to be set equal to 0. We have the x minus 1 that needs to be set equal to 0. And then we have the x plus 2 that needs to be set equal to 0. And you are going to solve each one of those. And then write your solutions. Do any of them occur more than one time? No. Okay, so we shouldn't have any multiplicities here because they all only occur once. But how many total answers should we have? How many? 3. Yeah. So the first one is just 0, right? What's the second one going to be? 1. And then the third one will be negative 2. Okay. When you are given a polynomial, just a clue on when you're solving these. I couldn't think of a word I was trying to say. When you're given a polynomial function that is not factored, the highest degree tells you how many solutions you should have. So if you have an x to the third, you should have 3 solutions. If you have an x to the 5th, you should have 5 solutions. Make sense? X to the 7th, it should be 7 solutions. So whatever, if it's not factored, the highest degree on your x is going to tell you how many solutions you should have in the end. So are we good with that? Right. Try this one. Hold on, let me see. Okay, I just wanted to see what I got. Try that one. Very similar to number 4. Again, set the f of x, turn it to 0, and then start trying to factor. You can also just look at your original function to make sure you know exactly how many answers you're supposed to get. We're working on solving this. So this one tells us that we're just saying that it's plus the percent. And I'm going to be the percent. Yeah, more plus each row. Yeah. So this one just not really. Yeah, so that means it's the same and I'll do it. And it just won't be. So it increments and you wouldn't have an x anymore. You would still have that x out from yeah, increments. And then set each one of those equal to 0. All right, I'm going to kind of do a couple of things at a time. I'm going to turn f of x to 0. And then, do these have a GCF that I can pull out first? Yes, what do they all have? X, okay. And if I pull that out, I'm left with x squared minus 7x plus 12. So again, I'm looking for the factors that multiply to give me 12 and add to give me 7. We don't worry about the signs until the end. Also, the x that you pulled out, don't lose it. It stays in the front. We're going to set up our two parentheses. We're going to split the x squared into x and x. What numbers multiply to give me 12 and add to give me 7? 3 and 4. Okay. If my second sign is a plus, my signs are going to be the same, and they are going to be whatever that first sign is. So in this case, they are both going to be negative. And then I'm going to set each one of these equal to 0, and I'm going to solve them for x. And if I look at my original function before I did anything, the highest exponent is what? 3, which means I should have 3 answers. Does it look like I'm going to have 3 answers? Yeah, I got 0, I got 3, and I got 4. Anybody have any questions on that one? We got one more, but this one's going to be a little bit harder with the factoring, so we're going to go through this one together. Is everybody ready? Sure, can't wait. Okay. All right, take a minute, write it down. We're going to go through this one together. It is a little bit harder with the factoring because we've got that number in front of x squared that we probably are going to have to deal with. Again, still looking to see if they have a GCF first. Again, we're going to replace f of x with 0, and then we're going to work on our factoring. How many answers am I going to have for this one? 4. My highest degree is 4, so I'm going to have 4 solutions. I'm going to go ahead and turn my f of x to 0. And what is it that they all have in common? An x squared, not just x, but x squared. Why is this one a little bit harder? Yeah, we got that number in front of the x squared. So not only are we worried about factors of 10, this time we have to include the 6 too. If you remember, when we had a number in front of our x squared, we either did the guess and check, or some of you preferred the cloud method. Okay, that is completely up to you. What I am going to do is go over to the side here so that we can work on factoring it. Then we'll come back to that. So we're looking at 6x squared minus 11x minus 10. You can either do guess and check, or you can do the cloud method. I'm going to do both. I'm going to start with the guess and check. Everybody ready? Okay. For guess and check, we're going to list the factors of the first term, and we're going to list the factors of the second term. What are the factors of 6? 1 and 6, or 2 and 3. And then the factors of 10 are 1 and 10 and 5 and 2. Okay, and remember we talked about we usually don't use 1 in the number. So I'm going to try the 2 and the 3 and the 2 and the 5, see if that works. If it doesn't, then we'll change it up. So I'm going to put 2x in the front and 3x in the front of the other. That gives me my 6x squared. Now, if I use 2 and 5, which number cannot go in the first parenthesis? 2. So I'm going to put the 5 here and the 2 here. And now we have to check and see if we're right. First of all, what am I trying to do? Add or subtract? Subtract to get 11. So let's take a look at what we have. We check the outside 2. If I multiply 2 times 2, what does that give me? 4. And then the inside 2, 5 times 3 is 15. Do 4 and 15 subtract to give me 11. Yeah, so I've got it correct in the first try. Now we have to place our signs. This says my signs are different, and the first one goes in front of the bigger number. So we're going to go minus 5 and plus 2. So I got 2x minus 5 and 3x plus 2. Let me come back over here. Keep the x squared. 2x minus 5 and 3x plus 2. And I'm going to pause for just a second because I want to show you the cloud method as well, for those of you who prefer that way. All right, so remember with the cloud method, we pull the first number off and we put it over here in a little cloud. We write the first term without it. Middle term stays the same. What do I do to these two? Multiply. 10 times 6 is 60. So now I have one of those easier trinomials. I want to try to factor. I want numbers that multiply to give me 60 and subtract to give me 11. 1 and 60 don't work. 2 and 30 don't work. 3 and 20 don't work. But 4 and 15 do, don't they? Different signs, bigger number, so minus 15 plus 4. That's not what I got, though, is it? No, because I still have my 6 hanging out here, so we've got to bring that 6 back in. We're going to divide each one of these numbers by 6. Is everybody kind of following me so far? Before I finish, I need to see, do these two numbers divide by anything? Do they have anything in common? 4 and 6. They can both divide by 2, right? So I'm going to divide 4 by 2, which gives me 2. 6 by 2, which gives me 3. And then what about 15 and 6? Do they have something in common that I can divide out? 3. So that turns to 5, and that turns to 2. Then what do I do with those numbers? Move them to the front. Denominators anyway. Does that look like what I got? Yeah. So now we're ready to take each factor, set it equal to 0, and solve. Keep in mind we're supposed to have 4 solutions. Exponents tell us about multiplicity, right? We have exponents here. I'm going to start with my x squared. That means I'm going to get what answer twice? Yeah. So when I write it, it's going to be 0 with a multiplicity of 2. This is going to be a little bit more tricky. I got 2x minus 5. We've got to solve this. What's the first thing I do there? Add the 5 over. So if I have 2x equals 5, what do I do next? Divide by 2. That doesn't go in evenly, but we can have fractions as answers, can't we? Yeah, so what would that fraction be? Just 5 over 2? Isn't that the fraction we had right over here? And then we're going to do the same thing again, but this time with a 3x plus 2. Oops, I meant to change colors there. 3x plus 2. We're going to do the same thing. Set it equal to 0. We're going to solve that for x. We're going to subtract our 2. We're going to divide by 3. And I get another fraction, and that fraction is a negative 2 over 3. Do I have a total of 4 answers? Yeah. So I got 0 with a multiplicity of 2. That's 2 answers. 5 over 2 and negative 2 over 3 for my total of 4 answers that we said we needed from the beginning. That make a little bit of sense? Okay. Some of them will be factored already for you. Some of them you will have to factor.